Is it showing now?
Yes.
Okay, good. Thank you for telling me this. So I'm going to go back and just restate what I said there, which was, first of all, remember the notation of for the derivative, and there's either f prime x or dy over dx, or d over dx of f of x, or capital D of x of f of x. So these are all ways that we denote. And I'm sharing with you a simple example of a function. And once again, I'll ask if you don't have a question, I'll keep going. But you remember how to differentiate. I showed you that last week. It's okay if you don't. I also, last week, talked to you about the first derivative function, where we would say, if we look at the limit as h approaches 0, given the function f of x plus h minus f of x, and all of this is over h. So that I did mention, and we're going to do one or two examples of that and see how you feel. So as I start the notes for this chapter, one of the things I want to talk about is the constant. So one of the students a couple of lessons ago asked me what happened to the constant when you did take the derivative. So let's say hypothetically, I have a function f of x, and we call that function, let's say it's 2x cubed, and I have a plus 5. And I take that first derivative, and I tell you that the function is simply 6x squared. And so the question is, what happens to this number? And what I want you to remember is this is technically 5x to the 0. 0 times 5 is 0. X to the 1, I take away 1, so it's x to the negative 1. Who cares? It's still 1. And even if I were to drop this as x, it's still a value of 0. So it kind of goes away, is basically what happens. The way the book explains it says basically that the first derivative of any constant will, in this case, whether it be some k value over d of x, and the value will always be 0 for that derivative. What they simply are trying to tell you is that if the function itself is a constant number, like the 9 that they use, then what they're saying to you is that first derivative, regardless, is 0. It's non-existent. It's just a value. They do the same when they explain, for example, if you have the d of t of the value for pi, which is a repeating term, that too is 0. So these are all examples. That's an example. That's an example. Then the third example is they say, well, what if I give you y is equal to 2 to the third? What is the derivative? Find the dy over dx of that, and that's still 0, because to the third is nothing but 8. So don't get freaked out by that. They give us an example that will refresh our memory of the function. So this is the constant. And remember how I showed you that if you have f of x, and that f of x is equal to x to the third power, and I said to you it's as simple as f prime x, that first derivative, is equal to 3x squared. And so they're showing us how the function that I introduced initially, where I said to you that the first derivative, that's going to equal the x plus h minus the f of x all over h. And we're looking at it as the limit of this function, h approaches 0. So when we plug it in, if they were to give us a function, let's say hypothetically, we would go back to the x cubed. Let me make that a little smaller. Then technically, this becomes f to the x plus h. Well, that becomes x plus h cubed. And so when we do this function, if we throw this into the actual values that we have for this equation right here, we know that this is going to become, this one particularly is x to the third. In theory, so I'll write it the whole thing. I don't know if you remember quadratics or the cubics and how you do that. So it's the two variables, a and b, in this case, x and h. And if you notice, the x has a 3, the h has a 0. That's why we don't even write it. Plus 3x squared, h to the 1, plus 3x to the 1, h to the 2. And it reduces further to plus x to the 0, h to the third. And yes, this is all over h, which looks ridiculous, but this basically goes back to cubing. Like if you have an a plus b cubed, this is a 1, 3, 3, 1 binomial. These are coefficients of that, which is why we have 1, 3, 3, 1. So this reduces, you end up with x cubed plus 3x squared h plus 3x h squared plus h cubed minus the f of x. Well, the f of x is our x cubed, so I'm just going to put it here in parentheses. And all of this is over h. So I just used this formula. That's what all of this is. Once I'm done with the whole formula, and this is lacking the f of x, so remember, the f of x is what I just added to the formula, which is this part right here. So you can see right here. So what happens is that, first of all, the x cubes are going to cancel because this x cube is positive. This one's negative. They're going to cancel. And now, since there's really not much that we can consolidate, I could start reducing. I know that h goes into h once, leaving me the 3x squared. I know this h goes into h squared once again, leaving me plus 3xh. And once again, this h goes into h cubed, at least once, to leave me with h squared. And so the first derivative, if I were to look at f of x cubed, I want you to remember that as h approaches 0, this cancels, because remember, the idea is the limit as h approaches 0. So your final answer is the 3x squared. Make sense? Absolute silence. What does that mean?
Yes, that makes sense.
Yes? Okay. Okay.
It's going a little bit slow with the writing, so it's taking a little bit.
Okay. You need a
Like it's not showing up as soon as you write.
You need a minute to take it in?
No, I was just letting you know why I didn't answer.
Oh, okay. Okay. All right. We're having bad weather here. That's why. I do want to talk to you about the power rule. So I want to talk to you about this next. And so what they're saying in this case, in the power rule, is that if f of x is equal to some x to the nth power for any real number n, so for any real number n, we say then the first derivative, f of x, that is equal to the d of x to the nth over d of x, which reduces as a formula to n times x to the n minus 1. And you already know that because that's exactly what you do when you have f of, say, x to the third power. We know that that becomes, the n value is a 3, so that becomes 3x to the 3 minus 1, which is how we get 3x squared. So I don't want you to get all freaked out when you see that formula and they try to throw that at you. I just want you to know that that's where that comes from. They give us some problems to try for the power rule, which are nice review. So we're going to refer to this as example 2A. And so example 2A, if I gave you the question, I said to you, find dx of x to the 6th power. Okay, so just take a look at the notation. The example is, or the answer is as simple as the derivative is 6x to the 5th. And again, this goes straight back to this formula. Is that simple enough for you? Or would you like to see another example?
Another example.
Another example? Okay, so what if I said to you, find d of x, and I gave you, say, x to the 9th? What would that be?
9x raised to 8.
Yeah, 9x to the 8th. And again, you're following the same formula. Is that clear for everyone to do?
Yeah.
Yeah.
All right. Okay, let me do example B. If I give you an f of t, and I said to you, find the first derivative. What is that first derivative of t? What would your answer be? I want you to remember this. This is no different than the previous example, because technically this is 1, remember this is 1t to the 1 power. So the derivative is simply 1. The reason behind that is the exponent 1 times 1 is 1. And if I take away 1, this becomes 0. T to the 0 is 1. So now I have 1 times 1, which is 1. That one is a basic, or what do you call it, a foundation concept. It's would be the only example I would have because we only have one variable or one number. But if I said to you, what is f of a, for example, your answer for this would be the same. It would be 1. Again, in theory, this is 1a to the 1 power. 1 times 1, that's simply 1. Take away 1, that becomes a to the 0. A to the 0 is 1, so it's really 1 times 1, which is 1. Simple?
Yes.
Awesome.
Yeah.
Yes.
So this example, if I were to say to you, I have 2x to the 4th plus x as a function, as an f of x. This would be a way we could put it together. If I ask you for that first derivative, then in that case, your answer would be 8x to the 3rd plus 1. So you're still dealing with this as being 1 x to the 1. Again, The idea is 1 times 1 is 1, again, times minus 1, this becomes x to the 0. We know x to the 0 as the value is 1, which is 1, so hence 8x cubed plus 1.
The 8x cube is because 4 times 2, right? You multiply the
Yeah.
exponent and that, and then there was just
Yeah.
okay, yeah, that makes sense.
And
Thank
that goes
you.
back, this goes back to here. This goes back to here, this concept right here. All of what I've done here from that point on is the same thing, just tying it together. I just need you to understand that when the variable sits alone, it's never alone. It always has a 1 attached to it somewhere. Okay. So in example C, I'm going to ask you if y is equal to 1 over x cubed. The question they're going to ask you will say find dy over dx. And I briefly went over this, I believe, yesterday or the last time I saw you guys. Just remember, when it comes to these types of questions, once you bring that variable up, the exponent becomes a negative. So this is really y equals x to the negative 3. And you really have a variable 1. So 1 times x to the negative 3 means that if I follow the pattern, negative 3 times 1, well, that's negative 3 x, and I'm going to take away 1, so this becomes negative 4. We now correct this because we don't like negative exponents, so this becomes negative 3 as a numerator over x to the positive 4. And that's your first derivative. That's the first derivative right there. Let's do a few more of these. Make sure you understand the process. So let's try if I said to you I have y equals 1 over x to the negative 5th. No, positive 5th. Let's leave it as positive. So okay, so what's the first step and how do we do this?
We write it as x raised to minus 5.
Yep. So this becomes x to the negative 5th. And now we follow that this is 1, right? Because it's 1 is a numerator. Next step, multiply. So you have 1 times negative 5 is negative 5, obviously x, and then take away 1. So now we're at negative 6. What's the last step?
We write it as minus 5 by x raised to 6.
Yeah, minus 5 over x to the positive 6. Make sense or no?
Yep.
Yes,
Just
Yeah.
one more, just in case, okay? So what do we have y equals negative 2 over x to the 7th? First step, this is negative 2 times what?
X raised to minus 7.
Yep. And the next step,
14x minus 8.
so it becomes 14x to the negative 8, right? Because it's take away 1. And your final answer? Positive 14 over x to the, oh my gosh, x to the 8th. Is everybody cool with that one?
Yes.
Okay, good. Let's do the fourth example. Fourth example in example 2 is if I'm given y equals the square root of something, anything, let's call it z. They want you to find the first derivative. Now, if you remember, any root is written as a fraction as an exponent. So this is really y equals z to the positive 1/2. That is the same thing as the radical. So the first step is you're going to multiply that value. So you're going to get 1/2 z. And remember, technically you have to take away 1. So this gives you negative 1/2. So we need to fix that. So to correct this, remember this is 1/2. And now this will be z to the positive 1/2. You can also write it as simply 1/2 square root of z. So either or, depending on what Pearson wants, because Pearson's going to ask you for. Is that easy enough? You want another example, or?
Can we do one more example with the square root?
Yeah, absolutely. So let's do, let's say we do y equals, let's do 3z, no, let's do 3 over, I'm having a moment, three times, let's do 3 times square root of z. How's that one? See if you can walk yourself there. So taking our time, the coefficient, remember this is now 3z to the positive 1/2. If I multiply these two puppies, this becomes 3/2 z to the negative 1/2, right? Because we're subtracting 1. That means I'm subtracting 2/2, which is going to give me the negative 1/2. And if I restructure this, remember, I want to bring this below the fraction bar. So it becomes 3/2 square root of z, basically. Or I can restructure this as 3/2z to the positive 1/2. Either or gives you the same answer. Did that make sense for you?
Yes.
Does anybody want to try another one, or you feel comfortable? We're doing great on time, so we're good. You tell me if you want another one. Keep going?
I could use another one.
Okay. Let's do, let's see if I can get you a good one. Let's do y equals 8 square root of z. So I'm just going to re-express this where it's 8z to the positive 1/2. Now I multiply 1/2 times 8. Well, that's going to give me 4. I still have a z, take away 1. It's still going to be negative 1/2, right? And now we simply want to correct it. So it'll be 4 over z to the positive 1/2. Or you can write 4 over square root of z. Your choice.
Okay.
So how do you feel?
Yeah, I get it.
You're good. Good.
Wait, can you go back up?
Go on.
No, it's the last one, the 8.
Right here.
Yeah. Wait, so
You got it?
no,
What's the question?
the First step, I get.
So you understand why I'm writing it as 8z to the 1/2, right?
Yeah, that part I get.
Okay, now the second part, if I multiply 1/2 times 8, what do I get?
4.
Right, and then I take away 1, what am I going to get here? So remember, when I take away 1, since the denominator is 2, this is really like minus 2 over 2. So I'm left
Okay.
with a negative 1/2. Does that make sense?
Um,
So in other words, look, I have 1/2. I'm taking away 1. But when I say 1, I really mean 2 over 2 because 2 over 2 is 1. And the denominator is 2. So if I do 1 minus 2, what do I get? Minus 1 over 2. That's the idea.
okay.
It didn't connect. So let's reconnect here. Let's do a similar example. So I'll do a 10 squared of z. If I do 10 squared of z, is it true that I'm going to write it as 10z to the 1/2?
Yes.
Okay, what's 1/2 times 10?
5.
Okay, I'm taking away 1. So 1/2 times minus 1/2 minus 1. That leaves me z to the negative 1/2, correct?
Yeah.
I then correct it. So it's really 5 over z to the positive 1/2. Or 5 over square root of z.
Okay, I'm getting the order of stuff.
Yeah,
mixed
just
up.
remember, it's the exponent first. So if you notice
Okay.
this one, it's the exponent first, so multiply that first, and then take away 1. So you're going back to this formula here. Where'd the formula go? It's here. This one. That's the basics of the formula right here.
Wait.
So it's always n times x first, then take away 1. So this part comes first, then take away 1. All right. Do you want one more before we continue? Can't hurt.
Yes.
I guess.
So let's do 16 square root of a. So what's the first thing you're going to do? Rewrite it, right? It's really 16a raised to the 1/2. Step 1, what am I going to multiply? What's half of 16?
8.
So you get 8a to the 1/2, but if I take away 1, I'm really taking away 2 over 2, which is going to give me 8a to the negative 1/2. What's the last step? Write the exponent as a positive, right? So to do that, I have to bring the a down as a positive 1/2. It'll come to you as we do more practice. Hang tight. Let's look at example 3. Actually, let me go to a new page. Let's look at example 3. And so in this one, they're asking us in part A, if I have y equals 8x to the 4th, they want us to find dy over dx. So that's just basically find another derivative, right? So this one, when I do the derivative, I end up with 32x to the 3rd. That makes sense? What's 4 times 8?
Oh, yeah.
32.
32. Take away 1. 4 minus 3. 4 minus 1 is 3. In part B, they ask you a very similar question, but this time they say y equals negative 3 over 4 x to the 12th power. What do you think the derivative is? Think about it. If I'm multiplying 12 times 3, I am going to end up with negative 36 over 4 x to the 12th minus 1. What's 4 goes in? How many times does 4 goes into negative 36?
-9.
Negative 9 x to the 11th. And that is the value of your first derivative.
Why would 12 only go on the top and the numerator?
I'm multiplying a whole number, which is 12 over 1, times a fraction, which is negative 3 over 4. And so this is how I get negative 36, and that 1 times 4 is the denominator. That doesn't change. And now divide 4 into negative 36. That's negative 9. All right. Example C. In example C, they want us to find the first derivative of negative 8t. Final answer? What happens to the t? It's a t to the 1 power.
Does it cancel out?
It does. It just cancels out because what you have here is negative 8 t to the first power. 1 times negative 8, well, that's negative 8. But we're going to take away 1, which leaves us with negative 8 t to the 0 power. Anything to the 0 power is 1. So you have negative 8 times 1, which is negative 8. So anytime you have, remember the power is always going to be a clincher here, because if you have negative 6t, for example, your answer will always simply be negative 6, whatever that coefficient is, because in theory, this is t to the first. And it always cancels 1 power. So if I had negative 6t to the second, then that becomes negative 12t. Make sense?
Yeah.
Yes.
All right. Good. I'm glad. Let's look at the next one. This should be interesting. In part D, they're giving us the following. They say find the derivative of p given 10p to the 3 over 2. But what is 3 over 2 times 10, which is technically, if you think about it, 1.5. What is 1.5 times 10?
15.
15. You can also think of it as 3 times 10, which is 30, divided by 2. So either way, it's 15. You take away 1, which is really taking away 2 over 2, leaving you p to the positive 1/2. Is it easy enough? We want to do another one?
One more, please.
Okay. So same question. So I'm going to give you d of p, find d of p if I have 10p, and let's make this 7 over 2. What is the value? 7/2 times 10, or 10/1, if that makes you happy. And then this is p raised to the 7/2 minus 1, which is minus 2/2. What do you get?
35.
Yes,
To
35.
the 5/2.
Correct. 35 with 5/2 for the p. Are you feeling that a little bit better, a little more confident?
Yes.
Yeah.
You want another one? No? Keep going?
Yeah.
Okay.
Keep going.
All right, part E. If I have y equals 6/x, I want you to find the derivative. Find dy over dx. Do you think you can do this one? We already did a few of these. What would you move? You have 6/x. Would you move this to be 6 times x to the -1, perhaps? And when you do that, if you multiply the number, this gives you -6x, take away another one, that gives you -2. Now you rewrite it. So technically this will be -6 over x to the +2. Final answer.
Whenever it's -6x, it'll always be -6x over something like, and as a final answer. They'll not switch.
You're talking about this being negative here, right?
Yeah, it'll always be -6x in the
Yeah, that stays.
answer.
That's this, yeah. The coefficient doesn't change. What changes is the variable and the exponent. Should we do another?
My dog was barking when you were explaining it, so I couldn't hear very well.
Yeah, sure. What you okay. I can do another one. So let's do 7/x, for example. If I said to you y equals 7/x, I want you to remember that the first thing you want to do is do 7 times and then bring this up as a negative, right? Because there's a positive down here. Now, if I multiply, my answer is going to be -7x, and this, if I take away another one, I get -2. I re-express it as -7 over x to the +2. Make sense?
Yes.
Yes.
Cool. All right, very good. I could do another one if you'd like, or we can move on. Your choice.
Move on.
Move on. Okay. Okay. I'm going to let me write a note for myself because I'm looking at the time and I'm starting to feel a little pressure. So I'm gonna put an X on this and I'm gonna put an X on this on page 3, and we'll come back to it if we have time. I'm gonna talk to you about a new concept called the sum or difference rule. And so this says if I have an f of x, some function, and I have that function, the first value of u of x plus or minus the v of x, if the first derivative of the first function and the first derivative of the second function is possible to get a sum and difference of. You can also look at this as the first derivative of the two functions. So we can think of it as the sum or the first derivative of that u of x, that first function, plus or minus that second function, depending on what they're asking you to do, whether add or subtract them. So to give us some examples, and as an example, they could say something like example 5, where they give us y equals 6x cubed plus 15x squared. And all we need to do to find that first derivative is simply find the derivative of each respectively, which is basically what this formula says. And this is a sum because we're adding. So this would become 18x squared plus 30x. If you remember, you multiply 3 times 6 to get 18. And then you take away 1 from the exponent. Same thing here, you might multiply 2 times 15 to get 30, and then take away 1 from the exponent. You end up with 30x to the first power. And that was example A. I could give you another example if you need. Let me know.
Yeah.
Okay, so all this craziness, that's why I want you to understand. Sometimes the calculus writers go a little overboard. All they're saying is, if I have some function, call it f of x, call it y, call it whatever you want, and I say to you, I have 3x squared plus 2x to the 4th power. Find the first derivative using the sum and difference. So you're going to say, okay, that the first derivative is simply equal to 6x in this case. That you understand where that came from, plus 8x to the 3rd. Does that make sense?
Yes.
And that's the answer. That's it. That's all they want. So all this mess, all that craziness, just to say that.
Basically, they want to see themselves talk, right?
Say again?
I said basically they want to see themselves talk, right?
I guess. I don't know. I don't know. But I like to see this a different way. Part B, example B. So let's call this example A. So in example B, we're still doing the same thing. They're giving us a function. They're saying if this is some function P of t, this is equal to 12 t to the 4th minus 6 square root of t plus 5 over t. Do you want me to give you a minute to see if you can get it? They simply want you to find the first derivative. Notice this one doesn't have just 2 values. It has 3 function parts. You want to try it on your own? Because we've done all of them, all 3 types. Would you agree with me that this is 48t to the 3rd?
Yes.
Would you agree with me that this is -3 and it becomes over the square root of t? Remember, okay, let me go back because I have a feeling this is where I'm losing some of you right here. In theory, this is -6 times t to the 1/2 power. Do you agree?
Yes.
What is 1/2 times -6?
-3.
-3, take away 1. So I'm taking away the -2 over 2, which gives me t to the -1/2. So I re-express it as -3 over square root of t, or t to the negative, or t to the positive 1/2. Make sense?
Yeah.
All right. And then same thing for this one. this is really 5 times t to the negative 1. Negative 1 times 5, well, that's just negative 5. Take away 1, that becomes t to the negative 2. So this is really negative 5 over t squared. Make sense?
Yeah.
So this is this first derivative of p of t. Well, that's simply 48 t to the third power minus, again, 3 over square root of t. And this becomes minus 5 over t squared. Okay. Do you want another example of this type?
Yes, please.
Okay. So let's say I have, let's go back to f of x. And let's say this is 6x to the third minus 4 square root of t plus 3 over t. Give that a shot. Let's see if we get it. What do we agree? What is the first term?
18x squared.
18x squared. What is this, the second term?
2 over 2 over t squared. Yeah.
Uh-huh. So you have 4t to the 1/2. Do we agree? To start? So half of negative 4 is negative 2. And you're going to have this over what?
Square root of t.
Yeah, square root of t, because that becomes negative, because you're going to subtract minus 2 over 2, right? All right, in the last term, the plus 3 over t, what is that going to become?
Isn't actually becomes subtracting?
Yes,
it-
it does.
3 over
Negative
2
3?
squared.
So it's 3 over t squared. Are you good? So this would be, all of this would be the first derivative. Are we good or no?
Yes.
All right. Do
Yep.
you want another one or no? I have several that are going to be really challenging. So get ready. So let me give you example C. In example C, I have some f of x, and I'm telling you that this is equal to 4x plus 6. And this is over the square root of x. So before you panic, I want you to see this. Basically, I have two fractions, believe it or not. This is really 4x over square root of x, and this is plus 6 over square root of x. And now I go through the whole process that I've shown you before. So since I have 4x, I'm going to raise the bottom. So this is really times x to the 1/2, negative 1/2, right? Plus, and this is going to become 6 times x to the negative 1/2. And now I begin to differentiate. So if I multiply this, I'm going to get a 2x to the negative 1/2 and this is plus. I'm gonna say plus, but it's really -3. And this becomes x to the -3/2. So as we continue, I end up with 2 over square root of x minus 3 over basically x square root of x again. This also reduces, and this becomes 2x minus 3 over x square root of x. Remember, common denominator, so we're multiplying by x top and bottom. So I know that one what must have been or will be a little bit more challenging.
Could you explain the -3/2 on the right side?
Yeah. Okay, so let's go back to the square one. I'm gonna square and start again. So we see everything. So the idea here is when you look at the equation, first of all, you split this up so you see that this is 2 exponents, right? Or two different parts of a fraction. All I'm doing is saying that if this is 4x, for example, I'm going to multiply that 4x times x to the -1/2. Remember, this is x to the 1. Okay. And over here on this side, I'm going to say plus, but technically I don't know that yet because this is 6 times x to the -1/2. So if we multiply these, this ends up becoming, remember when we add the exponents, so you end up with 4x -1/2 plus 1. So you end up with 4x to the negative, after you multiply it, so it's not -4x, it's actually 2. So we're jumping the gun. So 2x to the -1/2 for this part. And this becomes minus because -1/2 times 6, that'll give you -3x. This is -1 minus 1, so this becomes -3/2. Are we good so far? This is how I end up with 2 over square root of x minus 3 over x to the 3/2. Which, remember, the 3/2. Huh?
Can you go back to 6 times x?
Hello?
You lost me with the -3/2.
Yeah, I got lost there too.
This part here.
Yes.
Because I'm taking away 1. So minus 2/2.
What?
So -1/2 minus 2/2. Well, that's -3/2. Because remember, you're taking away 1.
Then wait.
So remember, you're always
Wait.
when you multiply first, that's how I get the -3. But then I have to take away 1. It's already a -1/2 minus 1 is -1/2 minus 2/2. So instead of 1, I'm going to use the denominator. And so that's how I get -3/2. But I want you to remember that this means that I have a 2/2 and a 1/2, which means that I have some x and some square root of x. which is why I end up multiplying by x top and bottom here, because I want a common denominator. So now I have the same exponent values. So now this becomes 2x
No, wait,
minus 3, and all of this over x square root of x.
I'm not getting it.
I'll do it again. See if it'll click. We'll click it again. Let's see. Let's see here. I'm just going to start from scratch so you can see everything from scratch. All right. And after this, I have to move on. And we can always have a consultation. It's not a problem. Okay. So going back, you understand this fraction, right? This is where we start.
Yes.
And you understand why I'm splitting the fraction up by dividing square root of x for both.
Yeah.
Okay. What I'm going to do is I'm going to take the 4x and I'm going to multiply it times x to the positive or negative 1/2. Remember, this is originally x to the 1. This is plus, and I'm going to say 6 times x to the negative 1/2. Okay. Are you with me so far?
Yes.
Okay. Now, if I combine like terms, I have an x to the 1 times an x to the negative 1/2. So this actually becomes 4x to the positive 1/2, right? Because 1 minus 1/2 is 1/2. When you multiply like bases, you add the exponents, don't you?
Yeah.
So I'm adding 1 minus 1/2, which is positive 1/2. Okay. Plus. Here, I only have 6x to the negative 1/2. This is why, at this point, I'm just going to rewrite it just to not confuse you with the steps. All I've done is rewrite it. Do you understand that?
Yes.
Okay. Now we're going to do the math part where we multiply the exponent. Let's multiply the exponent times the number. So 1's 1/2 of 4.
2.
2. X, and I'm going to take away 1. What am I left with? Negative 1/2, right? 1/2 minus a 1. All right, plus. Now, this may not be plus when I'm done. It's obviously not, because negative 1/2 times 6 is what?
Negative?
Negative
Oh,
what?
negative 3.
Negative 3, but I'm taking away 1, just like I did in the other one. I have negative 1 minus 2 is negative 3/2. The process did not change. You always take away 1 on the exponent once you're done multiplying, which was just exactly what I just did. Now, I rewrite it 2 over square root of x. Do we agree?
Yes.
Minus 3 over x to the 3/2. Which technically, this can be expressed as a power of 1 times the root of the same value. So x times square root of x with a negative 3 on top, that's what this term is. That's what this means. Because I have a 2/2. Well, x to the 2/2 is this x right here. I'm left with an x to the 1/2. Well, that's this square root of x. What I then need is to multiply top and bottom by x. So I have a common denominator. That's why my final answer is 2x minus 3 over x square root of x. Look, if it's not clicking for you, it will, but I have to keep going, okay?
Okay.
We can always have a session if you need a session one-on-one. Okay. The next question or part, for example, we have another function f of x. And this is equal to 4x squared minus 3x, and this is all squared. Basically, what you have is 4x squared minus 3x times 4x squared minus 3x. Okay, so if you want to FOIL, we can FOIL this times this. Well, that's 16 x to the fourth. Inner outer products, if I do the products, I get negative 24 x to the third, correct? And then last terms, these two, the 3x, negative 3x, this is positive 9x squared. Okay, if I want to find the first derivative of this, now we just differentiate. So that's going to give me 64x cubed minus 72x squared plus 18x. Is that terribly difficult, or you think you got it?
Got it.
Cool. Okay, given the value of time, I'm going to mark this page as a come back to, because I want to make sure that I cover quotient and product rule. Those are, I think, the last two things I want to do. I did want to talk about marginal analysis, but I'll probably send you a short little video clip on that. No more than 10 minutes, I promise you. But let me do product rule and quotient rule, because these are the two main strategies that you need for this section, okay? So let's talk about product rule first. Okay, product rule. I want you to write down this formula where if I have a function, let's say I have a function f of x, and that function is the result of some function u of x times some other function v of x. And I'll give you an example of this back to back. The first derivative is the formula where you take the value of u of x times the derivative of v of x plus v of x itself, the original function, and that times the derivative of u of x. So that's your formula for product rule. So let me follow up with a really clear and easy to follow example. So let's say u of x as a function is simply 2x plus 3. We know that the first derivative of this function is simply 2. If I do the same thing for the v of x, and I know that that function is 3u squared, I know that the derivative of this function is simply 6u. So far, so good. And I can go as far as we can color code it if it helps you. I probably will. So if this is the original u of x and its derivative, let's do it in green. So the first derivative of u of x is over here, and its original function is right here. Okay, so if that helps. And here's v of x. Let's go with teal for v of x. And that's sitting right here. And that gets multiplied by the purple or the pink color v prime x, the first derivative. If it helps you, just throw it in like this. Product rule is probably the easiest one of the two because of the fact that it's positive. You can't go wrong. So this is going to simply be 2x plus 3. And you're going to multiply that times 6u plus 3u squared times 2. As far as the substitution, it should be fairly easy. I wrote u's, and that was my mistake. I should stick to just v's. Sorry about that. These should just be v's. Or x's, I mean. So x's. And so if this is an x and this is an x, it won't be so confusing. So you end up with 12 x squared plus 18x. You're just multiplying it out. Sorry, being neurotic. Just making sure that we are good. And then the last term here is plus 6x squared. If you add like terms, you notice you get 18x squared plus 18x. And this reduces further, because if I take out 18x, this will simply be in here x plus 1. And that is your first derivative. This is the first derivative of the function, just using that simple method. I hear quiet. That usually makes me nervous. Are you okay?
Yeah.
Yeah, I'm just writing.
It
Yep.
took a second to put it together, but
But it did come together.
yeah.
That's good. I can make another example if you want. Or if you want to move on, we can move on. It's up to you.
And this is the one. This is always positive.
In the product rule, yeah, you have the benefit that it's positive.
Oh, quick question. How did it become 18x parentheses x plus 1?
What's common to both?
Oh, okay.
What's
I
common
see.
to both? Yeah. So once you
18.
yeah, so 18 and see if I want to try to find you another example if you want to do one.
Yeah, that's fine.
Bear with me, I have the book in front of me. I'm trying to find another example real quick. There's so many other concepts I wanted to talk to you about, but right now I'm kind of stuck like chalk because I'm limited to time. But that's okay. We're gonna get to a lot of other stuff. One quotient rule. Want to find one that's gonna make sense to you. Oh, we will talk about chain rule next time I see you. Can't wait for that. That'll be fun. All right, so product rule right here. So this
Oh,
is-
wait, I got it. It made sense now.
What's that?
I got why it's 18x parentheses x plus 1. It's just,
Had a moment.
yeah.
We all have moments. Let me see if I could get you a product rule. All right, so let's try to do if you have how did I write that product rule? I'm trying to find a fair one for you. Okay, what do we do? Square root of x plus 3. And I want the first derivative of the product of that times x squared minus 5x. So this is your f of x. I want the first derivative. So you would agree that this is u of x, right? And this is v of x. And if I find the first derivative of u of x, what am I getting? I should have 1/2 x to the negative 1/2. And I take the first derivative of v of x. Well, that one simply should be 2x minus 5. And so if I follow the formula, what are you getting? That's your next to do. So if I'm setting this up well, and again, I'm following the formula, this should be x to the 1/2 basically, plus 3. And this times the v of f, which is 2x minus 5. And this is plus the actual derivative, or the original v of x, which is x squared minus 5x. And this is times, like I said, the 1/2 x to the negative 1/2. So I'll go ahead and I'll distribute this accordingly. So x to the 1/2 times 2x, and the negative 5x. So I end up with the following. I end up with 2x to the 3/2 minus 5x to the 1/2 plus 6x minus 15. So basically all I've done is distribute 2x to the 1 times x to the 1/2. This gives me 2x to the 3/2. X to the 1/2 times negative 5 gives me negative 5x to the 1/2. Then 3 times 2x, well, that's 6x, and 3 times negative 5, well, that's 15. Okay, great. Now we do the distribution on the other side, which gives us plus 1/2 x to the 3/2 minus 5/2 x to the positive 1/2. If I simplify like terms, I'm going to get 5/2 x to the 3/2 plus the 6x minus the 15/2 x to the positive 1/2 minus 15. That's the first derivative. And obviously the idea is you would substitute in a value that would fit into the equation that you're looking for. If you're looking for a specific number, you plug that number in as a x, and then you get your actual sum value. Okay, I'm gonna finish with quotient rule, and I'm gonna keep going because if not, I'm never gonna finish. Let me do quotient rule. Now look, in quotient rule, what you need to remember is that this one does have subtraction. So the order in which you put in the values makes a huge difference. So, let me set for you the example of the actual, okay. So the actual function f of x. The f of x will be some u of x over some v of x. So for example, I could give you a 2x minus 1 divided by 4x plus 3. I know that the derivative of this one,
Shut up.
the derivative of this one is equal to 2. And I know that the derivative of this one is equal to 4. We could start with that at least just to make our life a little bit simpler. What I want you to remember is that this is the way you do it. So your first derivative as a formula always starts with the v of x value times the derivative of the u of x. Consider that inside a bracket mentally, or even like as you do the operations, minus another bracket, and this is going to give you u of x times the first derivative of the v of x. And all of this always is over v of x squared. So that's just how it is. It is how it is. So if you want to color code it, we can. So u of x in pink. Here's u of x in pink. The next value, the yellow, we could do the v of x original value. V of x is right here. And our derivatives, I'm going to do in teal, I'll do the u of x. So u of x in teal. And in, I guess, light blue, I can do the v of x. That's this value here. And again, v of x, the original derivative or function, has the denominator squared always at the bottom. So in this very easy example to follow, the first derivative in our case is simply the 4x plus 3 times 2 minus the 2x minus 1 times 4. And remember to think of this as brackets here. And all of this is over 4x plus 3 squared. Now, just a heads up, in Pearson, they usually don't ask you to FOIL the bottom. Leave the bottom as is unless they ask you to do so otherwise. When this is completed and you distribute, you're going to get 8x plus 6. That's the first half of the numerator. Minus, and if you distribute this, you get 8x minus 4. And all of this is over the 4x minus 4, minus 3 squared. Four x plus 3 squared. Okay, so remember, you're distributing this negative in here. So I'm going to do this in orange. That makes it negative 8 and positive 4. So that means the 8s are going to cancel. Your final answer here is going to be 10 over, and again, this is 4x plus 3, and that's squared. So that's the quotient rule. We're going to eventually get to chain rule and other examples. So if you're doing the homework and you hit a snag, for example, let's talk about for a minute about marginal profit, because I haven't talked to you about like the application of this. Marginal profit, marginal cost, marginal anything. You take the first derivative, that's what they're looking for you to do, and they're asking you to substitute in a specific value. Those are the examples that I just ran out of time. And I'll send you a short video and example question. I think it'll be enough for you to really take it home and be able to use it. I think everything else is pretty marginal analysis, marginal revenue, a marginal profit. I have it all here. And this is all part of what I owe you. time-wise. I'll send you a little snippet of it, and I'll send you some videos to help you understand how we use it, why we use it. Because remember, it's a rate of change. It's all about the rate of change with the derivative, all right? So next time I see you, we're going to talk about chain rule. And so you guys have your first exam. After you're done with this section, I think I gave you enough time to do the exam. And also your project question. I asked you to do that. I gave you some time on that too. If you find that you need a little bit of time to get this really under your belt, and you need just a little bit of time, whether it be a day or a couple of days, let me know. Okay, shoot me an email and let me know. But try to keep within the allotted time. Okay. So and if you need a question answered, you can send me a picture. I'll do the video response or send you back an explanation of some sort. You're not alone.
For the project,
Yeah.
am I supposed to have a picture of my work too with it, or just fill in?
I'm not asking for it.
Okay. When
But
it's
if it helps you and you find a way you can do that, then yeah.
okay.
Well, I have a question.
Go ahead.
If it shows there's a test and an exam,
Is it what?
it shows that there's a test and an exam.
There is
So
a test.
yeah, so it shows two of them in the grade section. So are there two exams or is just one?
No, just one.
All right,
It
and
should just be exam one or test one.
okay, and it's due Sunday night.
You're saying that there's two tests showing up on your thing?
Yeah,
Yes.
there's one through the 27th.
I'll look into that. I don't know what that is. I know that I
Yeah.
put yours. I think I put yours at the 24th. Right?
Yes,
Is that
there's one for
correct?
the 24th, and
Yeah, the
then there
24th.
says,
No,
and then there's another one that says the 27th for week 4, but it's due the 27th.
no,
No?
no. That's probably the one coming forward in the next section.
Yeah, but it says like due like 2 days after for some reason.
I'm the one that does the grades and puts them in. Don't panic.
Okay.
Don't
Okay.
panic. I'm telling you not to panic. So,
Okay.
yeah.
Oh,
And
So
try
it's due
calculus.
on
Calculus is
Sunday.
fun. Say again?
It's due on Sunday, right?
The 20 is that the 20, that's the 24th.
Right.
So yes, that one is due. Okay, so you have one exam, one project, and one more homework.
the
All right.
are both exams the same thing? The
No.
one that
No, did you only have one exam? The one that's due the 24th. That's it.
no, I'm asking, like, are they top? I downloaded both of them. I'll look at the first one.
You don't have two exams. You only have one exam, and it's due the 24th. The other exam, throw it away.
Okay, so we just disregard whatever that is then.
Yes.
Okay,
Only the
thank you.
24th.
Sorry, we just want to make sure so we don't miss
I
anything.
know. I don't
But-
even know why it's showing up there. So
No,
I'll correct it.
I'm asking, is it the same questions on both of them, or is the first link is the right one to pick?
The 24th, whatever's due the 24th.
Okay.
So
I have another
I'm gonna relieve your nerves. The minute we hang up from here, I'm going to delete that exam. Problem solved.
Okay.
All right.
I have another question.
Yeah.
So for the next exam, let's say, and there's another exam due after 4 weeks, let's say. So will we be tested from like weeks 3 to like 7 or like
Is
weeks
it cumulative? Is what you're asking? No.
Yeah.
This exam is chapters, from chapter 1 to I think this is chapter 4.2. About 4.2-ish, right? And then the next exam will be from 4.3 on and so on.
Okay.
But at some point, some of this material might come around again in a sense of it's you're learning the ABCs of calculus.
Yeah.
And I know that because when I was talking to you today, I could tell that you immediately were catching on to differentiation and simple constant rules, that kind of stuff. So some of it is going to sort of show up.
Okay. Thank you
Does
so
that
much.
make sense?
Yeah. Thank you so much.
So I think you guys are fine. All right, so I'll see you next week. Or if you have a question, send me the question. I'll happily answer you. Okay?
Thank you.
Have a wonderful rest of your
Thank
evening.
you.
Bye.
No worries. Hey,
Hi.
Jen.
Hi. I'm just quickly just stopping by and saying thank you for the project.
No worries.
There was just an issue. I guess the PDF file was corrupted. It did show
Yes.
up on my modules, but I couldn't like open the PDF file. So
Still?
no. Now it's fine. Now I've got
Okay,
it. I'm
yeah,
working
because we
on it.
saw
Yeah.
that. We actually saw that because we downloaded it like we were you. And we're
Uh-huh.
like, no, he's not wrong. So my what do you call it, class setup person also helped me with this. Course designer helped me figure it
Okay.
out.
Okay.
So
Good. Yeah. I just wanted to stop by and
yeah,
thank you.
no worries, no worries. How's
Yeah.
your golf?
Good. Now
Good.
it's after our second tournament.
Oh,
Unfortunately, the second tournament I got hospitalized with vertigo.
oh,
So I didn't play for the second round and I was in the hospital for a day. Yeah, basically.
ah. Well, hopefully
So
you'll do better.
yeah, but this week we're flying out to Florida. So that's gonna be fun.
Oh, it's gonna be hot.
It's gonna be hot, yeah.
Very hot. So yeah, definitely we'll tell you